Hi, welcome to product review by watthour. In this video we are going to do the review and test this APD5830 30 ampere back converter with input of 20 to 70 volts, output of 2.5 to 58 volts, 1 to 30 ampere step down converter. Test it with different input and output voltage. We will see the minimum and maximum voltage that this can accept and supply, and then we are going to test it with 800 watt and will come down with all standard voltages from input of 70 volts up to 12 volts and from output of 50 volts, 58 volts and down. So we're going to have a look at this power module, claimed 800 watt or 30 ampere, and this is a detailed video. Please use chapters. The larger screen, click on this area of the player so you can see all the chapters, and then click to move to that section of the video. On your mobile device you will see the menu. When you touch it you'll see all the chapters, and touch to move to that section of the video. First the module will be explained. After that, briefly, components will be viewed and input and output, and settings will be explained if there is any. And also we will demonstrate input and output minimum and maximum voltage so you can see how much you can set, and maximum output power and current will be demonstrated. At each step I'm going to show you the efficiency. Here are the main features. Input voltages from 20 to 70 volts. Output can be set from 2.5 to 58 volts, and output current 0.1 to 30 amperes supposed to be set. Maximum current is 800 watts, and we will pay attention to this. We will do it practically, and it's supposed to have constant current and reverse polarity protection. We must know that the maximum power is 800 watt, and also they say it is 30 amperes, so whichever comes first. So you cannot always get 800 watts, and also you cannot always get 30. In some instances you get the power, sometimes you can get the current. Please don't forget to subscribe. And here on AliExpress some stores are selling it for $32 plus $11.46 US, and another store is selling it for $46 plus $13 shipping. Here on eBay, if you search 800 watt step down converter, you see that there are multiple sellers selling it at around $40 less and more. And this is the package, how I received it. Let's just open it. Whoa, this is huge. Very solid build, nice, good connectors. And here, wow, this is much better. We can solder thick wires if we want, and this is amazing. And let me explain some of the major components on this. And this is the input, N negative and N positive. They have been labeled. We have a 20 ampere fuse here. So maximum input cannot exceed 20 ampere. Filters, these are rated with 100 volts, so we can connect up to 70 volts. And this is an optocoupler. Perhaps this is the main switching module for the input, and this is the pulse width modulation switching controller. This is op amp, and these are the three shunt, perhaps each 10, so total 30 ampere for the output. These are the filters for the output. These connectors here, these are just for reference. I was just checking it. This is one is for the voltage, the other is for the current, and this is for on off. So you can if you short circuit these two pins, the output will be turned off. CC, that's for the constant current, this potentiometer, and this is for the constant voltage. And we have a load LED here, but we don't have a constant current LED so far that I have not found. Inductor is very well built, and soldered properly, so there is no vibration with this glue. Let's open it. I removed these 4 screws here, and also the 2 screws that were attached to some semiconductor. Let's see if so. There was another screw, long screw. All screws have been removed. Let's just lift it, and here, this is H3708. This IRF 3708 is a MOSFET, 62 ampere 30 volts MOSFET. It is N-channel MOSFET. And these are HY 3810 MOSFETs. There's a datasheet for HY 3810. This is 100 volts, 180 ampere N-channel enhancement mode MOSFET. Let's see if they are the same model. These are diodes for MBR 3100, and here is a datasheet for MBR 3100. Each is 10 ampere MOSFET. This is rectifier. Inside one package we have 2 diodes, so one of them can handle 10 ampere, so this will be 20 ampere if you put them in parallel. Pulse modulation generator that they have removed it. Then we have some here, an op amp. Now it's time to thumb up the video and also hit the subscribe button. Now let's see if we can set the current for charging battery. So I'm doing the output terminals of this short. Either this dies and it proves that it is dying, or it can survive with the maximum current 30 ampere. So as you can see, it was too much spark on my pens, and yes, the fuse has blown. As you can see, the fuse has blown, and here I have to replace it back with another one. And here, let's have a look at the thermal image, and you will see that this is 120 degrees Celsius at this spot. That's 110 degrees. When I put my finger, that's a chip. And here is my setup. Input current is displayed here, input voltage. These 2 wires have been connected to my power supply. These 2 wires are AWG8. This is connected to my electronic load, where you will see the output. Also I've connected remote sensing so we can get accurate reading. This is a control software for my electronic load. We will be reading power. I've magnified it. We will see the current, the output, and the output voltage. Now let's start our test. Input is 70 volts, as you can see. Output is 58 volts. That is the recommended setting, even though I went up to 60 volts, but the problem is that these output capacitors have been labeled at 63 volts, so it's very dangerous. If you go above, they will just pop out, explode and burn. So we will never go above 58 volts to be safe. Voltage sensing is here, and I have bent it so the fan is free. Now we have 448 watts, and this is the input current, 6.7 ampere, and 7.8 is the output. We will increase it. As you can see, the voltage has dropped 1 volt, even though we have sensing, so that's a fault from this module, because the input is still steady, and I have very thick wires to be able to handle it. Let's increase it. I just jumped to 530, 57 volts, still acceptable in terms of percent. So now we are at 570, I'm just increasing it. So now I'm running 600 watts exactly. The voltage has dropped. You can see output current is now 10 ampere, 10.5 at 56.97. It has dropped. Now let me turn off the load. As you can see, the voltage is 58 volts. Let's turn it on. So 1 volt drop. Now it's 600 watts. And here is the efficiency with 600 watts. I've set the output to 700 watts. Output current is 12.28 ampere. Voltage has dropped a little, about 1 volt. Input current is 10.45 ampere at 70 volts. And here is the efficiency. Now I have set it to 800 watts. Let's run it. And here 800 watt is now the output, the maximum power that this can supply. 70 volts is the input. 12 ampere is the input current, 11.95. And we have set it to 800 watts. Let's run it. And here 800 watt is now the output, the maximum power that this can supply. 70 volts is the input. 12 ampere is the input current, 11.95. And output current is 14 amperes, 14.07. Let's keep it for a few minutes to see. So the cooling fan is still very cool. Unbelievable. This is very good quality. Now let me show you the thermal image, and this is unbelievable. 43 degrees. The hottest spot is here, 43 degrees, where my finger is. And let me rotate it. We don't block the fan. Now this is the thermal image. On this side, 56 degrees is the hot spot. Let me put my finger exactly in here. So this is very cool. That is 54 degrees at this spot. And what is the hot spot? 37 degrees. And now the output is 48 volts. That's another standard voltage. Let's go with 800 watt first. (16.6 ampere is the output, and here 800 watts. Input is 70 volts. Input current is 11.7 ampere. And here is the efficiency. This has amazing efficiency. Now I'm running 400 watts at 48 volts. Input current is 5.8 ampere now at 70 volts. And here is the efficiency. It's 800 watts at 36 volts. The voltage has dropped about 200 millivolts. Input current is 11.8 ampere at 70 volts. 800 watt. Output current is 22.3 ampere. The voltage is dropping now. Now it's good. The voltage is also steady, the same as before, 200 millivolts. And here is the efficiency. Now I set output to 24 volts. So the current is set to maximum. Let's go 600 watts. Still cannot do it. 500 watts. Watt is working. So 20 ampere at the output. 24 millivolts drop. Still acceptable. So 500 watts at the output. Input current is 7.57 at 70 volts. And here is the efficiency. Now I've set output to 18 volts. Let's go with 500 watts. So here 18 volts, we have around 230 millivolts drop. 28 ampere is the output. 500 watts. Input current is 7.78 ampere at 70 volts. And here is the efficiency. And here is now the thermal image. It shows 70 degrees Celsius at this spot, exactly in here. So the same spot underneath because of the components. Now I have set output to 12 volts. Let's go with 400 watts. So 400 watts did not work. $350 does not work. So 300 is working now. And with 300 watts, and with 300 watts, 25 ampere is 25.6 is the output current with 12 volts, and 4.85 ampere with 70 volt is the input. And here is the efficiency. Now it's time to thumb up the video and also hit the subscribe button. Now output is 8.4. That's a 2-cell lithium battery charge voltage. Let's go with 300. It doesn't work. 250 watts doesn't work. 200 watts does not work. $150 doesn't work. $100, 8.4. The voltage has dropped, as you can see. If I turn it off, the voltage is 8.4. When I run it, the voltage, now even that one does not work. So 100 watts, the output is 12 ampere at 8.3. The voltage has dropped. Input current is 1.57 at 70 volts. And here is the efficiency. So 15 ampere. At 5 volts, the voltage has dropped significantly, about 140 millivolts. Input current is 1.27 ampere at 70 volts. Now output is 3.3 volts. As you can see, the voltage is now fluctuating even though there is no load. Now 12 ampere at the output with 3.3. As you can see, the voltage dropped. So this is not a good option to use 70 volts as the input and get 3.3. But here is the result, 37.2 watts. Now I've changed the input voltage to 60 volts. Output is set to 50 volts. I am going with 800 watts. Let me turn it on. So now output is 800 watts, 16 ampere at 50 volts, and the voltage has, as you can see, has dropped now. This was 50, now it's 48, 87.2 volts drop. And input current is 13.6 ampere. $700 watts. So now this is 700 watts. The voltage has dropped now. 14.3 ampere. Input current is 11.9 ampere. So output is 36 volts. Let's go with 700 watts. And now it's 700 watts. Output is 36 volts. Let's go with 700 watts. And now it's 700 watts. Output current is 19.3. Input current is 12 ampere, 12.1 with 60 volts. And it is holding very well. Here is the efficiency. Now output is 24.3 volts. We know it will have some drop. Input is 60 volts. Let's go with 700 watts. So it did not work. 600 watt did not work. 550. So we are getting 550 watts. And here are the voltage and current, 22.8 ampere at the output. Input current is now 9.7 ampere at 60 volts. And here is the efficiency. Now output is 18 volts. Let's go at 550 watts. So it did not work. Let's go 500. 400 watts. So 400 watt is working. Now output is 12 volts, input 60 volts. Now output is 36 volts, input is 48 volts, a new voltage, 500 watts. So this is now 500 watts, and here is the voltage and current, 13.9. Input current is 10.65 at 48 volts. So that's 600 watt, 16.7 with 12.8 ampere at the input. Here is the efficiency. Now the output is 700 watts, 19.5 ampere at 36 volts. The voltage has dropped a little, 119 millivolts. Input current is 15 ampere at 48 volts, and here is the efficiency. Now I set output to 24 volts. With 36 volts, output is 24 volts at 25 ampere, 600 watts. We have 17.54 ampere at the input. Here is the efficiency. Output is 12 volts, input is 36, 25 ampere, which is now, as you can see, voltage has dropped and it is 293 watts. 9 ampere input, 36 volts, and here is the efficiency. Now output is 5 volts, the voltage has dropped 100 volts, 25 ampere, input current is 6.3 ampere at 24 volts, and here is the efficiency. So here is my conclusion. In terms of build and shape, it looks very nice. Huge heat sink with fan, very quiet fan. The connectors are excellent. The output voltage, however, drops around 200 millivolts or 300 millivolts, so you have to compensate it for your application. That's the bad thing about this. And also I tested it that this cannot be set. You cannot set the current limit with this because you have to do the short circuit. As soon as you do the short circuit, you will burn the device, as this died now, and this op-amp is now heating up. So something is wrong with this, and I have no time to repair this or buy another one. Not worth it. Because I was not able to set the current, I could not do the charging battery. Very important to know that if you cannot set the current, your battery will get damaged, because constant current will help to reduce the voltage. So if you cannot set it, then for charging this is just useless. In this video we are going to do the review of this 50 volts 20 ampere Wurji WZ5020L back converter, 20 ampere or 1 kilowatt.